All right, so today's lesson is 4-5, proving triangles congruent using the ASA and the AAS rules. So we've already done a few lessons here in chapter 4 talking about proving triangles congruent, and we talked about some of the rules that we can use, right? So triangles have 6 parts. They have 3 angles and 3 sides. When we have 2 triangles, if we know for a fact, either it tells us or we can prove mathematically that all 3 angles are congruent in the 2 triangles, and all 3 sides are congruent between the 2 triangles, meaning corresponding parts, right? This top angle is congruent to this top angle. This guy is congruent to this guy. This guy is congruent to this guy. So all these angles are congruent to all these angles. Same with the sides. If we prove that, then we can say the entire triangle, not just angle A, angle B, angle C, but triangle ABC is congruent to triangle LMN. And if we've proven all 6 parts are congruent, then the rule we use is called CPCTC. Corresponding parts of congruent triangles are congruent. Then we had some shortcuts, right? This was the long way. This is the one long way. Prove all 6 parts of 2 triangles are congruent. Then you can say the triangles are congruent because of CPCTC. Then last week we learned these 2, right? So we learned the SSS postulate and the SAS postulate. SSS is when we prove just the 3 sides. So we don't even care about the angles. We don't look at the angles. We don't need to know about them. If all 3 sides of one triangle are congruent to corresponding sides of another triangle, then we have enough information there to say that the entire triangles are congruent. So everything about these are congruent. Even though we don't yet know about the angles, we automatically know that they're all congruent because the 3 sides are congruent. And that's all we had to know to prove the 2 triangles are congruent. Right? To prove 3 sides are congruent, side, 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 we can say that the 2 triangles are congruent. Another one that we learned last week was side, angle, side. So instead of proving all 3 sides are congruent, we only have to prove 2 sides are congruent in our 2 triangles, not congruent to each other in one triangle, but when we're looking at one triangle, 2 of our sides are congruent to 2 sides in a different triangle, right? So 2 sides and the angle connecting them, the angle in between them has to be congruent as well. So side, angle, side is congruent to side, angle, side, SAS. Just like the A is between the 2 S's, the angle has to be between the 2 sides, right? And if that's the case, then we know this entire triangle is congruent to this entire triangle. All we had to know was that these 3 parts were congruent, and we can go ahead and make the leap and say, then everything in them must be congruent. So this week, we're talking about the last 2 shortcuts. We're talking about these 2 right here. In this first lesson video, we're just gonna focus on ASA. In the second lesson video, we're gonna focus on AAS. But basically, to summarize in short, ASA is just like it looks, angle, side, angle. So we can prove that 2 angles and the side that connects them are congruent to 2 angles and the side that connects them in a second triangle. And if we show that, then we know the entire triangles are congruent. So all we have to know is that 2 angles are congruent to their corresponding angles in 2 different triangles, and the side that connects them, and we call that an included side. It's the side in between these 2 angles. So it has to be that included side. It has to touch both angles that are congruent, and if that's the case, we know the entire triangles are congruent. So that's ASA. AAS, the last shortcut we have, is when 2 angles are proven congruent in our triangles. We don't care about that 3rd angle. As long as these first 2 are congruent, we're good. And then a non-included side. So up here, ASA had to be this line in between our 2 angles. For AAS, it has to be one of these 2 lines that's not in between our 2 congruent angles, right? So either of the other 2 sides. I marked this top one congruent. It could have been this bottom guy because either one of these 2 sides are non-included. They are not in between these 2 angles. The only side in between these 2 angles is this guy. If this is the one congruent, then we're looking at ASA. But if it's not in between these 2 congruent angles, then we're looking at angle, angle, side. Angle, angle, and then a side. The side is not in between the 2 angles, right? Hopefully that makes sense. That's a little shortcut version. All right, so to focus on just the first one, AAS. Sorry, ASA. I'm already getting them mixed up. ASA, this guy. The postulate's listed right here. It's basically what I just told you. If two angles and the included side, the side between them, just like here, the A's and the S between them, the angles and the side between them of one triangle are congruent to the corresponding parts in another triangle, then the entire triangles are congruent. So we're going to do a quick proof kind of example here. We have 1, 2, 3 of them to do, and then we'll finish this video up. All right, write a 2-column proof. If AB is parallel to CD, and it's already marked parallel here, and angle CBD is congruent to ADB. Well, this requires there to be a line right here, and there's not a line drawn. So I'm going to draw this sort of arbitrary line. It's part of our problem. It wasn't included in the problem, but we need to go ahead and draw it in to kind of visually see what they're talking about. Okay, so it tells us these two angles are congruent. That would be this angle and this angle. And the only other thing it tells us, to prove triangles are congruent, I have to show at least 3 different things are congruent. So I need at least 3 congruency statements. Right now I only have 1. I've only shown that 1 corresponding set of angles is congruent. So I need 2 more things, right? And I'm focused on the ASA rule. So I'm looking for another angle and a side. I've already got 1 angle. I need another angle and a side. Okay, so I'm going to go ahead and write this in my proof. I get ahead of myself. AB parallel to CD and angle CBD congruent to ADB. And that's our given. Okay, so the next thing I can say, they don't really waste information in a proof. So whenever it gives you something, a little tidbit or a fact, it's given it to you for a reason. So we want to use that, right? We've already marked this part. We need it for the end. We don't have to do anything with it. This parallel statement isn't a congruency statement, which means we're going to use it to figure something out. So if I know this top line is parallel to this bottom line, and I've got this transversal here, what else do I know? Well, I could say that this angle down here is congruent to this angle up here, right? The measure from my diagonal, my transversal, to this bottom parallel line is the same measure as the same transversal to this top parallel line. These are alternate interior angles. They're in between my 2 parallel lines on different sides of my transversal. So I can go ahead and mark that here in my proof. I'm going to say angle, what is this, CDB is congruent to angle, and then this top one, let's call it ABD. Looks kind of similar to the one above it, but it's not the same, okay? And the reason I know that they're congruent is because it told me the top line and the bottom line are parallel, and if that's the case, the alternate interior angle theorem tells me that when I have alternate interior angles between 2 parallel lines, they're going to be congruent. Okay, so now I've got 2 different angles in this top triangle are congruent to 2 different angles in this bottom triangle. And my goal here, the proof, is to prove this entire top triangle is congruent to this entire bottom triangle, right? So the last thing here, if I just look at one of my triangles, if I just kind of hone in on this top guy, I have this guy congruent and this guy congruent. I'm trying to use ASA. So if I have 2 angles, what's the third thing I need to prove the triangles are congruent by ASA? The side between the 2 angles, right? This guy. So can I say that in this triangle, this line is congruent to this line in this bottom triangle? Yeah, it's the exact same line, right? We're going to use the reflexive property. We're going to say that here, this line DB is congruent to itself. It's the same size, whether we use it in the top triangle or whether we use it in the bottom triangle, it's the same size. So this hypotenuse of the top triangle is the same length as the hypotenuse of the bottom triangle, and that's because of the reflexive property. Whenever you say something equals itself or it's congruent to itself, that's reflexive. Okay, so now, I'll go ahead and mark it here. Now I have enough information. I can say this triangle is congruent to this triangle because of angle, side, angle. Or in the bottom, angle, side, angle. right? So I'm gonna go ahead and write triangle ABD is congruent to triangle CDB because of angle, side, angle. And it is the angle, side, angle postulate, but when you're doing proofs, you don't have to write the word postulate. You can just write ASA. All right, cool, let's do another one. You are gonna have these in your homework. I just finished making the assignment, so I do wanna go through examples so you guys can kind of use that to help you. All right, so here, write a 2-column proof, same thing. Here's our diagram. So it tells us S and V are congruent. So here's angle S, here's angle V. And it also says that T is the midpoint of SV. So SV is this entire line. T is in the exact center, right? So step 1, I want to list that. Angle S is congruent to angle V, and T is the midpoint of SV. I'm abbreviating a little bit. And the rule I'm using for number 1 is because that's what was given to me. Okay, line 2. What else can I say now? Why did it tell me T is the midpoint of SV? How can I use that piece of information? I want to use everything in the given. I've marked this congruent. I'm going to use that. How do I use the bottom piece? Well, if T is the midpoint of SV, then I know ST has to be congruent to TV. This guy has to be the same size as this guy, right? So I'm going to say ST is congruent to TV. And why is that? The midpoint theorem, right? Or definition of midpoint. Midpoint theorem. Midpoint theorem says that when you have a midpoint on a line segment, it splits that line segment up into 2 congruent half segments, right? Okay, so now we've said 2 different things are congruent. We've got an angle and a side. And up here, we can see we've got an angle and a side. What else in this bow tie shape do we know for a fact is also going to be congruent? The vertical angles, right? We know this angle is going to be congruent to this angle. We can't say angle T because there's 4 angles at point T, so we got to be specific. But we know these 2 angles are vertical angles, so they are congruent. So down here, for step 3, I'm going to say angle, and I'm going to call this side, I'm going to call it RTS. RTS is congruent to this side, I'm going to call it UTV. Angle UTV. Down here, angle RTS is congruent to UTV because they are vertical angles. So that's the vertical angle theorem. Extend my line a little bit. Okay, so now if I look at my picture, sorry, that's kind of crooked. If I look at my picture here, I can see in this triangle, I've got angle, side, angle marked congruent. And in this triangle, I've got angle, side, angle marked congruent. So I can go ahead and say that my 2 triangles are congruent, like it tells me here, because of ASA. So step 4, triangle RTS is congruent to triangle UTV. I hate when I run out of room and I gotta stagger it like that. And why do I know the entire triangles are congruent? Because I didn't prove everything was congruent, but I did prove an angle, and the included side were congruent in each one. So that's enough. So I can say these are congruent by the ASA postulate. ASA. Cool? All right, one more. This actually says write a paragraph proof, and you will be given that sometimes. I'm going to go over a flow proof today in the next video, so we can start using those as well. So for a paragraph proof, we're going to go over the same logical reasoning, but we're just going to kind of write a quick little paragraph, right? I'm going to write it in blue since it's next to here and I don't want it to run together. All right, so given that CD bisects AE, so CD, this line, bisects AE, if this line here cuts this line in half, that's telling me that these 2 smaller halves are congruent, right? AB is parallel to CD, so this guy is parallel to this guy, and angle E and BCA are congruent, so this guy and this guy are congruent. I have to prove that these 2 triangles are congruent, right? So I've got to use everything it gives me. It only gives me 1 congruency statement here. I need 3, at least 3, to prove these triangles are congruent. So it gives me this one. I'm not writing a 2-column proof, I'm writing a paragraph proof. So I'm going to say, I know that CD bisects AE. So I don't care what English you use. So based on the or by the definition of segment bisector. So by definition of, I'm going to abbreviate. You should not abbreviate, but since I'm doing this on the video, I'm going to abbreviate. Segment bisector AC is congruent to CE. Okay, so there's my first sentence. I just have to write an entire kind of paragraph listing this stuff out. Okay, so that was based off the first part here. Then it tells me A, B, and CD are parallel. I also know AB is parallel to CD. So what does that tell me? What can I come up with based off of the fact that this line is parallel to this line? Well, these two lines, if I like extended them out, you know, they're being cut by this transversal, right? So I know this angle and this angle are going to be the same size because they're, oh, sorry. This little angle here and this little angle here are going to be the same size from these two parallel lines cut by this transversal because they are corresponding angles. If I drew a little box around this guy and a little box around this guy, they're going to be in the same little window pane in the same position. Okay, so now I can say that this angle BAC, so angle BAC is congruent to this other angle right here, which is, what was this, D? No. It's C, D, E, A, B, C. Oh, the C. DCE, I'll call it. Angle DCE. So I know those two angles are congruent because of the corresponding angle postulate. By the, again, I'm going to abbreviate. Please don't abbreviate when you're doing this. You have the time to write it out. I'm doing it on video, so I don't. Corresponding angle postulate, which says when lines are parallel, cut by a transversal, any corresponding angles are congruent, okay? So now I've got two congruency statements. I've got this line right here is congruent to this line. I've got this angle is congruent to this angle, and then it tells me in the given, I haven't listed it yet, but it still tells me up here that these two angles are congruent. So I'm gonna list that last. Finally, I know angle E is congruent to angle, what is it, BCA. So I can say triangle ABC is congruent to triangle CDE, my proof. Because of what? I've got an angle, a side, and an angle marked congruent to an angle, a side, and an angle. They're corresponding. So that's angle, side, angle in that order. Two angles and the included side. So I can say my triangles are congruent by the ASA postulate, or you could just say by ASA. Okay, so that's my little paragraph proof. It's literally the exact same thing as over here, but instead of listing just stuff out, I put them in sentence form. That's it. Just kind of thought through it logically, okay? Let me know if you have questions on that, and make sure you watch the next video.